in Singapore, and with you Anna Tutava, co-founder of Cointelegram, and our guest Dominic Williams, who is founder of Dfinity, the company building internet computer. Great to have you here, Dominic.
Thank you, Anna. Good to be here.
Yeah, I remember you were here, not here, but as well at Token2049 in Hong Kong in 29 March, and I first got acquainted with your company, and now you're making such a big progress.
Yeah, so Dfinity is a foundation based in Switzerland, and we run blockchain's largest R&D operation, and we're the biggest contributor of technology to the internet computer blockchain, which provides a world computer that is a blockchain where you can build with smart contracts without the usual limitations of low efficiency, slow speed, and so on. And this internet computer does a lot of remarkable things. For example, smart contracts running on the internet computer can process HTTP requests. Mm-hmm. So now you can build a Web3 service entirely on the blockchain and have it serve the user experience directly to end users without relying on traditional IT like centralized big tech cloud computing services.
And can you tell your story? Which year did you get into crypto blockchain?
Well, there are many parts to it. So actually in the latter half of last century, going into .com, I was building a kind of platform for sharing files online that did some kind of clever compression to move things around over the very slow internet connections people had then. And of course we were using cryptography to secure the connections. And I was using a C++ library called Crypto++, created by a guy called Wei Dai. And I read his proposal for something called B-Money. Mm-hmm. This was in like 98, 99. And honestly, at the time, I was in my 20s, I didn't understand it at all. But I sort of saw there must be something really exciting there, I just didn't understand it. And I think that stayed in the back of my mind. And then in 2013, I was still running a computer game I built, a massively multiplayer on the game, had millions of users. And I'd been, through my work on this game, been doing a lot of distributed computing work. I'd use this, the game was using this database called Cassandra. It's the first sort of database that has a decentralized architecture and can scale its capacity without bound, really. I'd engineered a horizontally scalable game server called Starbucks. So essentially what that means is we created a platform that made it very easy to scale the interactivity provided to millions of people playing this game. And I'm very passionate about distributed computing and cryptography and things like that. So 2013, Bitcoin caught my eye, like many other people's eye, because it went on this incredible rally in April. And one thing led to another, and I read Satoshi's paper and just thought this is the most incredible thing that I've ever seen. It almost like what I dreamed would be possible, and here it was, a truly decentralized network, which was not configured and controlled by anybody, that provided a very useful service. And so by the end of that year, I was working full-time in blockchain, initially trying to create a cryptocurrency for the games industry. Not surprisingly, because I'd just come out of the games industry, and I got the domain name Gamecoin, and I wanted a cryptocurrency that would allow people to buy and sell virtual goods and exchange virtual goods and move the value they accumulated between games. And I saw this was...
So it was some kind of your concept of NFTs, so was
it was, that's right, yes. Actually, the game was called Fight My Monster, and every monster in the game that users had was unique. It was generated. And these monsters leveled up their powers over time and had histories and things like that. And so they're really like early NFTs. And they gained a lot of value, and users would trade these things. So I thought, wouldn't it be great if somebody could create some valuable monsters on my game, sell them to other users for cryptocurrency, and then take that cryptocurrency to another game. And it would create this kind of cross-game economy that would be very exciting. So I soon realized that the throughput requirements for virtual goods would be very demanding. So soon I was working on a blockchain called Pebble, which was designed to process hundreds of thousands of transactions a second. And it was also going to do some other things like enable like crypto-based subscription payments to remove advertising from services like Facebook. And so I spent 2014 doing technical research for that, pioneering in two ways. Firstly, I was the first guy trying to use traditional, what's known as Byzantine fault-tolerant consensus mathematics and adapt it to the for the creation of blockchain protocols. And of course, everyone does that now. And secondly, I was the first person who was trying to create a blockchain that could process just vast numbers of transactions a second. So I think, I published a paper in 2014, but didn't really share it widely. And the reason was I was kind of already moving on. I didn't want to do Pebble anymore. And people can actually hold that paper if they're curious. They go to the internetcomputer.org page and go to the history link, and it's up there if people want to look at it. The reason I moved on is I kind of connect with the Ethereum community. And the early Ethereum community is just an incredible thing. And within that community had arisen this idea of a world computer, right? A world computer. And the reason being that for the very first time, we were seeing that a blockchain could host code. So we call blockchain code smart contracts, but it's just software, right? It could host a special form of secure and stoppable software, and all of its computation, that computation and data. And so, I think for a lot of people, that vision was kind of limited, more like a world calculator, right? We're just going to do some basic DeFi on the blockchain, and that's going to be enough, thank you. But when I heard this term world computer, it struck me between the eyes. It was a sort of epiphany for me that, wow, you could create a blockchain that would play the role of a world computer, and it could run all of the world's online systems and services. And these would have tremendous advantages. Firstly, they'd be built on a public network. So you wouldn't be the captive customer of a closed proprietary infrastructure like Amazon Web Services. Secondly, they'd be built with smart contracts. Smart contracts have magical properties. They have properties that normal software doesn't have. For example, smart contracts are tamper-proof, guaranteed to run the correct logic against the correct data. So you don't need a firewall. Right? You don't need a firewall to protect Bitcoin. You don't need a firewall to protect smart contracts on Ethereum. And when you build online systems and services on the internet computer using smart contracts, which plays the role of a world computer, you don't need firewalls. And even just that's groundbreaking and a game changer for IT. I mean, this year in 2022, the world will spend $172 billion on cybersecurity. Firewalls, SIEM logging, security teams. Well, guess what? When you build on a world computer, the internet computer, you don't need firewalls, you don't need cybersecurity, because you're building using smart contracts. Smart contracts, though...
but still, some smart contracts can be hacked, breached.
They can. I mean, I think a lot of the vulnerabilities that you see in smart contracts on, for example, Ethereum, or smart contracts more generally based on the EVM, Ethereum virtual machine, a lot of the hacks and the vulnerabilities derive from deficiencies in the design of the EVM. It was back when the EVM was designed by a guy called Gavin Wood, who was the sort of CTO of the Ethereum project at the time. He personally hadn't really much experience in the design of virtual machines. There weren't any other virtual machines available. The use cases were pretty limited. And one example of a major security flaw in EVM and other blockchains that leads to these security problems is reentrancy, right? So actually, smart contracts don't really run independently on the blockchain. One smart contract calls another smart contract, calls another smart contract. It's all on one stack, and it enables things like flash loans to take place. But in practice, it's a bug, not a feature, and it results in a lot of problems. So obviously things have moved on a lot, and the internet computer uses the uses WebAssembly as the virtual machine. WebAssembly is extremely performant, well proven, formally verifiable, is used within browsers, and it's indeed run by all major web browsers and used now for the back end of the web to on the internet computer.
And basically you have as well cloud storage, and there are a couple of other companies which do the same. For example, probably the most well-known is Filecoin. How is your solution is different from theirs?
Well, that's I think a major confusion. Filecoin isn't a blockchain, or IPFS. I mean, IPF is a protocol there that sits in front of decentralized file storage. But in the end, the storage is generally actually on big tech. So, if you want your files to persist on IPFS, you need to pin them. And to pin them, you need a pinning provider. And those pinning providers generally just put your files on S3, on Amazon Web Services. So that's very different to our vision. We don't want to build on big tech, we want to replace big tech. And this file storage service isn't a blockchain, it doesn't run code. The internet computer is a blockchain, albeit one that runs with hundreds of thousands of times more efficiency, much greater speed, and so on. And you build using smart contracts, and you store the data inside smart contracts. So a smart contract on the internet computer is known as a software actor. It's a bundle of WebAssembly bytecode and persistent memory pages. These smart contracts, unlike on other blockchains, can run in parallel, and that's one of the ways that the internet computer scales its capacity as needed. And you can use them to build pretty much limitless Web3 services. You could build a social network on the internet computer. Today, for example, there's, I always talk about this when I talk about the team, there's tons and tons, hundreds and hundreds of services being built, but there's one called OpenChat, which is like an online messaging service. And not only are smart contracts serving the user experience into your browser or mobile desktop, but also the smart contracts are processing the individual chat messages, even multimedia chat messages. And the messages are all being stored on the blockchain by the in smart contract memory. So, that allows you to decentralize the storage of dynamic data, not structured dynamic data, not just files, and build Web3 services end-to-end on a blockchain without any need for traditional IT. And that means that you can run those services under the full control and management of community DAOs and make users owners and part of the team that runs the services.
And can you share some other use cases and projects in your ecosystem?
Well, here's the best way of thinking about it. The internet computer is a world computer, and our mission is blockchain singularity. So we want to see it replace traditional IT, and every single system of service built on the blockchain and running from the blockchain without any need for traditional chain. So if you give me any service, I'll explain to you how I can build an internet computer. Right now, people are building a huge range of services on the internet computer. The difference is when you hear about built on Solana, built on Ethereum, built on Avalanche, built on Near Protocol, what that means is built on Amazon Web Services, and the users interacting with the service, the data on Amazon Web Services, and just a few tokens and NFTs being kept in the blockchain. When you hear someone say built on the internet computer, it's something very different. It means that the entire service, such as a mass market metaverse service, is built on and running from the blockchain itself. And smart contracts are doing all the processing of data and the storage of data, and even serving the user experience. So that gives you an idea of how different this thing is.
And as well, recently there were the news about crypto leakage, about Avalanche, and you were
crypto leaks.
Yeah.
Yeah, I mean, I don't want to get much into that. I would say that we're supportive. I think it's great that stuff's being, this kind of stuff's being investigated by journalists, and I'd recommend to everybody who hasn't seen it to go and have a look. But just stay out of it.
And can you share your thoughts on the development of the crypto markets? What trends do you see?
Well, the crypto markets, I think, kind of irrational. I think there's not much connection between crypto prices and how well projects are doing, the technologies involved, the teams behind them, and so on. crypto markets remain driven by kind of crowd sentiment, and the way you drives crowd sentiment is with can be with social media bots and hype and advertising. I think over time, crypto markets will become more rational, and that will be very healthy for the ecosystem.
And can you share some future plans for the development of Dfinity and Internet Computer?
I mean, there's so much. If people go to internetcomputer.org and go to the roadmap.
Actually, it's impossible to open it here in Singapore. I don't know why.
Internetcomputer.org is blocked?
Yeah.
It's blocked? No. Okay. I think
okay,
it's,
maybe from this Wi-Fi.
maybe it's just maybe it's just on this way. It should be possible, and there's crazy powerful features coming out all the time. So just recently, the smart contracts on the internet computer gained the ability to create transactions in other blockchains, sign transactions, using a great innovation in cryptography called shaky crypto. And this means you can create DeFi contracts for Bitcoin. There's no wrapping or bridges. Your smart contracts on the internet computer can directly create Bitcoin addresses, receive Bitcoin, and send Bitcoin on the Bitcoin ledger without an intermediary. And people have used other APIs associated with that functionality just recently to create a fully decentralized clone of the front-end user experience of Uniswap. And people are now able, using this decentralized clone, to authenticate using a fingerprint on their laptop or a Face ID on their phone. And smart contracts on the internet computer will actually create a signed Ethereum transaction that can be relayed by the front-end app and allow people to trade on Uniswap without ever touching a cryptographic key. So I think some of these things, the full importance of them will take some time to sink in, but this is like a huge step forward for crypto, because you've always been able to build fully decentralized services on the internet computer, where the smart contracts serve the web experience and process all the data, but that hasn't been possible when you use other blockchains until now. Today we're just passing a threshold where DeFi services on Ethereum, say, will be able to fully decentralize by taking their front-end experiences off Amazon Web Services and rebuilding them on the internet computer so they run entirely from blockchain.
Yeah, that sounds exciting. Thank you for the interview.
Pleasure.